Hi there. Today we are looking at adding fractions. Now, as we've seen before, a fraction is made up of two numbers, the numerator and denominator. The numerator being the numberer, tells you how many of something there are. The denominator telling you what on earth we are talking about in the first place. So, for example, if we see something like 2/7, then that tells us that we're dealing with sevenths. So that's sevenths, because the denominator is a 7, it's sevenths, and it's two of them, so we have 2/7, in exactly the same way that we have 2 oranges, or 2 lamps, or 2 teeth, all for example. So the big thing to remember is that you can only add or subtract numbers of exactly the same type of thing. So you can only add things of exactly the same type. So if I have 2 lamps and I have 3 lamps, then I can put them together and get 5 lamps. If I have 2 oranges and I have 3 oranges, I can put them together and get 5 oranges. But if I have 2 lamps and 3 oranges, well, you kind of know it, don't you? You know you don't have 5 of anything, you just have 2. I think it said 2 lamps and 3 oranges. Now, if, for example, you have 2/7 plus 3/7, then that's going to very easily come out as being 5/7. Now, notice the 7 here is still a 7. We haven't gone 7 and 7 is 14. We have sevenths. Now, this is one of the reasons it's so important to speak properly when it comes to math. This is 2/7. Sure, it is 2/7, and this is 3/7. But the correct way to pronounce it is 2/7 and 3/7. Now, if you hear that, you can hear in the English that 2/7 and 3/7 is just like saying 2 lamps and 3 lamps, or 2 chairs and 3 chairs. And you know that 2 chairs and 3 chairs is 5 chairs. And in the same way, 2/7 plus 3/7 is 5/7. Now, this is when the denominator is the same, and that's all very straightforward and hopefully makes complete sense. The real problem comes when we find ourselves trying to add fractions with different denominators. So let's take a new example. Let's say, for example, 2/3, okay, plus 4/5. Okay, so we'll say we've got 2/3 and we've got 4/5. Okay, so we've got 2/3 on the left there and 4/5. Now the problem we have here is that thirds and fifths are different things. They're different size things. That's like saying 2 apples and 4 oranges, or something like that, or 2 pounds and $3. Sorry, yeah, so $2 and 4 pounds, or something like that. The point being that we're talking about different types of thing. So in theory, that means we just can't add them. We can't add thirds to fifths. Thirds and fifths aren't the same sort of thing. We can't add them. But the solution to that is, well, the problem is they're different types of things. The solution is, let's make them the same type of thing. So that brings up the question, how can we turn thirds into something, or fifths into something that makes them the same type of thing? They're not the same, so we have to make them the same, so we have to somehow turn them into something else. And this is where we can use our knowledge of equivalent fractions. So we already know, for example, that 2/3, I'll make a note of it here, that 2/3 could be turned into 4/6, or 6/9, or we could turn it into 8/12, or we could turn it into 10/15, or we could turn it into 12/18, and so on. We also know that the number 4/5 could be turned into let's say 8/10, or could be turned into 12/15, or could be turned into 16/20, and so on, and so on, and so on. If you can't remember how to do this, check back the video about how to work out equivalent fractions. But the main thing to realize here is that whatever you do to the numerator, you have to do to the denominator, and it's a multiplying or dividing thing. So, for example, 2/3, if I multiply the 2 by 4, I get 8. If I multiply the 3 by 4, I get 12. Hopefully that refreshes your memory. So what do we turn 2/3 into, and what should we turn 4/5 into? Well, if you look along the denominators here, you can see that they have in common 15ths. So 4/5 can be turned into 12/15, and 2/3 can be turned into 10/15. Okay? So 2/3, as we can see here, 2/3 is the same as 10/15. So I'm going to make it the same as 10/15. Okay? And then we're still adding, so I'm going to make sure I have a plus sign there. And 4/5, as we saw here, 4/5 is the same as 12/15. So 4/5 can be turned into 12/15. Okay? So 2/3 and 4/5 you can't really do because we've got different denominators. So the solution to that is make them the same. Now that we have 10/15 and 12/15, this is really straightforward. We can add them together, and 10/15 and 12/15 makes a total of 22/15. How do I know it's 22? Because 10 and 12 makes 22. But it's still 15ths because it's like saying 10 chairs and 12 chairs makes 22 chairs. Okay? So we end up with a total of 22/15. Now, 22/15 is a top-heavy or improper fraction, and that means that we can change it to get a final answer, and that final answer is going to be 1 whole and 7/15. Again, that's really another topic, which is turning improper fractions into mixed fractions. But just to go over that again, if I have 15/15, that is 1 whole, so 15/15 is 1 whole, but I've got 22/15. 22 is 7 larger than 15, so my 15/15 makes up 1 whole, and then I have the other 7/15. Okay, so hopefully that makes sense. Anyway, just to go back over it, when I'm adding fractions, the denominators have to be the same. Why do they have to be the same? Because you can only add things if they are of exactly the same type. If they're not the same type, then you have to change them into something that they have in common, hence the lowest common denominator. How do I know what number to go for? Well, I can just think through what numbers 3 goes into, but 5 also goes into, and very quickly I find the number 15. Okay? Why is it 10/15? Because if 3 is multiplied by 5 to make 15, then the 2 must be multiplied by 5 to make 10. Why is the 4/5? Why does that become 12/15? Because if the 4 is being multiplied by 3 to make 12, then the 5 needs to be multiplied by 3 to make 15. And that's equivalent fractions in action. We're saying that 2/3 is the same as 10/15, that 4/5 is the same as 12/15, and that when I put these together, it's the same thing as if I put these together. The only difference is these have got the same denominator, so I actually can put them together, and the 10/15 and the 12/15 together make 22/15, which is 1 and 7/15.